finish by today for chapter 5, and then we need to continue for chapter 6, yeah, because now we are in week 10, betul kan? Mana semua orang ni?
Yes, betul.
Dia dah week 10 semua dah apa? Tak ada semangat ke apa? Harap-harap masih lagi ada Okay, so we have a look again with our planning, so that we are on the good track of our lecture. Semua nampak ya? So kalau kita kat sini, we are in week 10, 11, supposedly that we are start with chapter 6, which is on the wastewater. So today we are going to finish the chapter 5, okay, only a few parts. We are up until flocculation, right? So flocculation, sedimentation, filtration, and today finish up until the disinfection, right? And then wastewater treatment, maybe half of it. And then next week I'm trying to finish your chapter 6. So that's our tentative for today. So how's everyone today? Good? Semua sihat?
Very good, Doktor.
Good, Doktor.
Sehat.
Sihat, Doktor. Okay, that's good. Alright. So this is wait ya, nak kena share dulu. To continue for chapter 5, yeah. Actually, I've asked everyone to do the tutorials, right? The second tutorial for water treatment. Betul tak? So I think better for me to just go through the answer. Sekejap ya, saya check dulu. For the tutorials, I think last 2 weeks on water treatment about this question, 8 May. Okay, betul so the green indications means you are submitted according to the deadlines, whilst the rest, red ni tak hantar, not submitted. The red means you are late. Okay, that's okay. Okay, let me explain to you the solution. The tutorial is like an exercise only to discuss, especially on the calculation part. Ini bukan tutorial 4, this is second one. Chapter 5 on water treatment. Okay, first question, list the complete process or stages for surface water treatment plant in Malaysia with its brief explanation. Sebelum saya jawab, kita nak tanya dulu siapa yang boleh jawab ni. Kalau tanya volunteer ada ke? Is there any volunteer to answer this question? Tak ada. So kalau tak ada, saya tanyalah. Kan, to warm up. Saya nak tanya, Fatin ada? Fatin Nur Aina?
Ya, saya.
So apa the process of this surface water treatment for first question?
Sekejap Sekejap.
Okay, first apa?
Dia punya proses ke?
Ya, proses dia ada macam-macam kan, dia treatment proses dia apa dia?
Kejap. Ni ke? Hmm, Pre-chlorination,
Ya, lagi, then?
rapid mix,
Okay,
flocculation,
okay. Aeration tak ada?
apa?
Aeration.
Ya, aeration,
Lepas tu?
filtration,
Hmm,
settling,
okay.
sedimentation.
Okay.
Tu je ke?
Tak tahu lah awak refer kat mana tu? Google ke atau dalam slide?
Slide, tapi jap eh. Ya kot.
Okay, terima kasih banyak So basically mesti ada aeration kat sini. Okay, saya tunjuk kat sini lah. Aeration, then pre-treatment, that means this is the mixing of chemicals. Chemicals in order to, is either some water needs to do the softening, which means you need to add the hydrated lime, or in this process you also need to add alum as a coagulant to do the coagulation process. Okay, so kat sini lah. And after that is the flocculation, maknanya means that this to encourage the formations of flocks. Dia akan perangkap semua benda-benda colloid or particles, make it bigger. Okay, segala partikel yang kotoran lah, your dirts in the water. Okay, once the flocks is being formed, right, it will getting heavier, dia akan berat. So dekat sedimentation is the process of the settlement of this flock. Okay, so dia akan settle ke bawah lah, right, kat sini. Okay, then kita kena filter lah because we want to separate the flock and we want to get only the clear water. So this is the filtration. Usually we use a sand filtration, sand, gravel, some combinations of filtration as well. Okay, so this one looks like it's clarified. Maknanya dia dah seems in terms of water being remove all the turbidity, colloid and everything due to this before this previous process. But we are not sure. Maybe it still contain the certain viruses or bacteria. So in this part, we need to put the chlorine, biasanya kita panggil. Chlorine, we add chlorine to disinfect. Okay, untuk basmi kuman. And this is the regulation by the departments of Ministry of Health. So we also add some fluoride, okay, for our teeth healthy. Okay, now it become treated water. So that means it's ready to being distributed to the consumer. The consumer is either for the domestic use or for the commercial or industry use. Okay. Okay, that's the first process. So basically, you must master this process in order for you to know this chapter, how to treat your water, so that you can get and have knowledge now. You just push the tap on and get the water, right? So as a civil engineer, you must know the process behind this. Okay, then purpose of aeration in water treatment, I think I have asked before during the class, right? So this one basically the purpose of aeration to remove taste and odor. Okay, this is like a preparation and also to improve the water quality. We want to oxidize the iron and manganese. We want to produce more oxygen in the water. Okay, and then also we want to remove the H2S that make the fault odors. Okay, then you can also explain about the hardness. Hardness, we have discussed before in chapter Chapter berapa? Chapter 3, right? On the water quality. Okay. You have also been thought of how to calculate the hardness. Right. Siapa masih ingat lagi? Ni semua dah jadi pelupa sebab banyak sangat makan kuih raya. So basically the hardness formation is like this lah to make it, to summarize. Precipitation ialah macam hujan ada turun, the rainfall, this is the topsoil and also the subsoil. Okay, basically in the soil we have the subsoil and limestone. So the process in the subsoil ni ada carbon dioxide with water contribute to this bicarbonate, right? Bicarbonate ni kemudian dia react with the calcium and magnesium in the limestone. So that's why this produce this, what we call that, the substance that make the water hard. Okay, calcium bicarbonate ataupun magnesium bicarbonate, yang ni yang soluble. Okay, kalau banyak, then what happens if the water hardness is high? Tanya ni. Yep. Losh ni ada? Losh ni. Okay. Apa dia? When the hardness level is too high, what's happened? What's the effect? Saya tu macam ada keluar dekat test, right? Tapi just calculation, right?
Process.
Tapi dia masuk lagi, kita jumpa lagi sebab in
it increase the amount of soap level.
Increase what? Amount of?
Soap needed and leaf stains on plumbing structures.
Oh, okay. So if you want to wash your clothes, it doesn't effective, so you need more soap. Itulah kan? And then it form scaling in the, what we call that, the apparatus ataupun pipelines lah Okay, due to the formations of the scale of calcium and magnesium Okay. Okay, question number 4 is about the jar test. Jar test of this untreated water. Okay, this is the easiest way on explain in the lab, right? In the laboratory, when we have the water with certain turbidity. Turbidity tu apa? What is turbidity? Saya tanya juga. Ada siapa nak jawab? Turbidity tu apa? Muhammad Faris Hazwan? Muhammad Faris Hazwan ada?
Ada doktor, ada.
Turbidity tu apa?
Dia punya keruh.
Ya, betul kekeruhan, betul. Okey, kekeruhan. Dia punya level lah. Kalau 10 ni keruh ke tak keruh ni? Berbanding dengan 45. Mana satu yang the highest turbidity then? Muhammad Fahmi? Okey lah. Lambat sangat nak jawab. So maknanya yang that means ada 10 NTU means this is got the highest stability lah. Okay, maknanya dia kekeruhan dia lebih tinggi compared to the rest. So dekat sini, in this question, they injected or they added the alum dose. Okay, what's the purpose of alum? Adding alum? GIU.
Yes, Doctor.
What's the purpose of adding alum?
Alum. used in water treatment plant to clarify drinking water.
Yes. Okay, tu macam jawapan dekat Google ke dekat slide ya? Okay. So dia
Ada
kat mana?
not
Dekat tekno. Okay, that's good. So that means this is one of the example of coagulant kita panggil coagulant. So when we add this coagulant, it will absorb the turbidity, the particle to make it flop. Yeah. Itu the reason is to clarify the water. Okay, estimate the optimum alum dosage for turbidity. Kita nak cari yang mana yang paling efficient, the dosage of the alum. Okay, between these varying concentration, mana satu? Because even though that when we add highest alum dose, not necessarily can give the highest turbidity removal. So we need to plot the graph like this. Okay, the turbidity and also the alum dosage. Okay, based from this graph, you need to find the lowest point of turbidity kat sini lah. Yang ni lah kat sini kan. So basically kat sini kalau kita tengokkan, Allah hilang pula dia punya ni. Kalau boleh you buat dekat dalam kertas graf yang proper lah. So 16 mg per liter alum dosage yang needed to give the very lowest turbidity level kat sini 16. Okay, then we can calculate the amount of alkalinity that will be consumed at the optimal dosage. Okay, alkalinity means in here that how much is the bases ataupun because we want to know how much the water can give a buffer of the changes for pH. Okay, so if you are not clear, please read again. What does it mean by alkalinity? Okay, in here, you must know the molecular weight of the alum, right? So in here, actually example ada dalam slide ya. From the reaction of this alum with water, it can give this molarity, right? For example here, from the optimum value of alum, 16 kan, kita ambil yang 16 lah. Okay, must divide by the molecular weight, 594. Yang ini ialah just conversion, dapatlah yang ni. This is the molarity of the alum added ya. Yang ini kalau tanya saya, actually you can refer in the slide, which is from the reaction, which means 1 mole of alum will consume 6 moles of alkalinity. Yang ini ialah alkalinity. Okay, your alkalinity. So molarity of the alkalinity consumed is kalikanlah 6 moles. Okay, with yang you dapat ni molarity dia. So 1.62 times 10 power of negative 4 moles per liter. So you can calculate the concentrations of alkalinity consumed, okay, dengan dia punya molecular weight of alkalinity. So you will get 9.9 mg per liter. So if you want, because usually, because for alkalinity, usually we express as a calcium carbonate as a hardness. So kena you need to calculate based on the equivalent weight, right? Yang ni you need to refer again in the slide from the chapter 3 on water quality and how you calculate this one. 50 divided by 61. 61 tu dia punya molecular weight. Yang ini dia punya equivalent weight for calcium carbonate yang ni. Okay, then you can get 8.08 mg per liter as calcium carbonate. Okay. Yang number 5 ni lebih kurang sama, alright, tapi dia more on straightforward. So you can have a look. So that this solution I will share in the author so that you can check the solution. Is it okay? Especially for those who are submitted to me lah as a record, but I didn't mark for this exercise, but I will discuss during the class. Yeah. So thank you yang submit That means you give your effort, which is good. Otherwise you didn't know lah how to solve the question for chapter 5. Okay, any question for tutorial before I move to our next lecture on flocculation? Ada soalan tak?
Tak ada, doktor.
Okay, semua faham lah Kalau tadi saya teruskan untuk flocculation. Rasa pun saya ada explain before about the flocculation. Senang je kalau tengokkan ni, this is a very long explanation. Actually the process of binding the particles, okay. Before this we add the alum, right? We add alum. And dalam masa proses kejap ya. Kan, before this flocculation, apa proses dia? Kita panggil sebagai coagulation. Right, coagulation means we add alum in the water to make it flock. So in this process, kali saya kena pakai saya punya yang biasa pen digital Yang ini dekat screen susah sikit. Dekat sini. Okay, proses dia membesar lah, the flock become bigger. We want to enhance their bonding. So the process is we call it a bonding of the van der Waals forces to form a very large particle. Kalau besar lah bagus, because when it heavy then it will easily to settle. Macam tu lah. So this is the process. Basically the particles or our dirts, kotoran-kotoran in the water that we want to remove is negatively charged. Okay, so when we add this alum, bukan, not necessary alum lah. Kita panggil sebagai coagulant lah Coagulant ada juga kita gunakan ferric sulfate, ferric chloride There are lots of the coagulant Tapi yang biasa kita panggil kita guna ialah alum lah yang ni, sebab dia ada apa namanya, positive charge ni, heavy lah, dia lebih heavy So when they attract and combine, it will become heavier, so that's why it's easy to settle. Nak perangkap dia punya negatively charge ni Okay, so the purpose is finally we want to be like this, the bigger flock, right? And then it will be settled down at the bottom of the flocculation tank. Macam tu. Sekejap Saya nak tukar saya punya pen sekejap. Okay, takkanlah saya teruskan. Tak boleh, kena download dulu. So that's okay. Okay, this is the flocculation tank, yeah. In order for us like a baffle chamber, or it can be a pedal flocculant.
Sorry, doctor. Doctor, you are not sharing your screen.
Oh, sorry. Sekejap ya. Okay, nampak?
Nampak doktor?
Okay. Sekejap. Oh, yang ni. Okay, so kita boleh proceed lah. So this is the flocculation tank, right? So we have this like a baffle water level to increase the flock formation. Okay, because after this we want to remove the flocks. So we want to make sure it becomes it will attract or absorb all these particles. Okay, the dust to make it to make the water clear. Then this is in order for us to know the effectiveness of the flocculation. We can calculate this efficiency of the mixing, right? And then depends on the velocity of the gradient. Saya tukar laptop ni, that's why I'm not really familiar with this one. Ini velocity gradient dan juga mixing time ya. So mixing the velocity gradient in order to make sure that the particles contact and keep the flock from the settling but low enough to prevent the flock from the tearing apart. And then for the mixing time of this process, it will take around 20 to 40 minutes. Okay. So these are the few questions. Right, in flocculation tank, flow through velocity is normally to this one. Right, taklah tinggi sangat, not really high, because we want to encourage the formations of the flock. So what happens if the velocity is less than 2.5 or more than 7.5? Dia ada macam jawapan dia. Okay. Jawapan aku dah ada Okay, saya baca ke sini So if less than 2.5, the flock will settle, but we don't want flock to settle. We want the flock to, what we call that, to form more flocks, or make it larger particle or larger flocks. If 7.5 millimeter per second, flock will break up. Dia akan tear apart. So we don't want this one to be break up. So within 12.5 to 77.5 is the what we call the range that usually the flow is very good. through this velocity is also very good, so that they make this absorption process. Okay, in designing a fluctuation tank, which one of the following parameters take more priority? Is it the horizontal or through the velocity or detention time? So in here, we must consider the horizontal flow through velocity, halaju because we don't want the flock to settle too fast, dia mendap ke bawah too early, ataupun dia break up, dia not become a larger flocks. So this one we need to make sure that the velocity must in the range, suppose like that. And then a detention tank is not used to control the water to become septic while passing through the tank. So this is less important. Okay, flow collection and settling tank should be as close as possible. Why? Because in order for the flock to be settled or mendap, become a precipitation, so easy for them to side by side, so that the process will be happen effectively. Okay, this is the softening process. I think I have discussed with you before about why does this occur, especially due to the process of the natural geology side, geology kat sini lah, because the limestone contains very much of the calcium and magnesium. Okay, and then this affect the water supply, that makes the water becomes hard. Ada tanah-tanah yang kandungan dia memang kandungan dia banyak lah, kandungan minerals. Okay, I think I have discussed with you before in chapter 3 or chapter 4, I forgot. Chapter 4, right? So these are the process of the combination. What does it mean by temporary hardness? Okay, permanent hardness. I think we have discussed before. And then okay, for the permanent hardness, we usually in the water treatment plant, they use the lime soda softening, okay, in order for them to remove the hardness. Okay, this is only the examples. Lime, kapur is very important for them to make sure that the water is less of hardness. Okay, because if the water hardness level is very high, the water cannot be used or very inefficient to be used for washing. Kalau cuci baju, you need more soap. Sometimes that's not efficient. And then the most important is in the industry, they will what we call that give scaling formation, okay, in their pipeline system, right, in the boiler system and so on. Next becomes very critical for the maintenance, and which means they incur more cost for maintenance. Okay. Okay, after the what we call the flocculation process, now the particle being absorbed as a flux. Okay, the flux become more bigger and become heavier. Then this is a time for them to settle at the settling basins, sedimentation tank. So in here, they must control the flow, very low flow, and at least for 3 hours. 3 hours of the process for this settlement. Okay. So that we can collect at the bottom and remove it by using the mechanical process. So there are various types of the sedimentation tanks. We can use sometimes rectangular, yang A ni rectangular. Yang the second one is the horizontal, the circular one, right? And then the third one is a hopper bottom outward flow. So this is the examples of the circular clarifier, bulat. So this is the process of how the water being inlet of the water entering the system, the sedimentation tank, and then the settling zone, the settlement zone, and the outlet is the water becomes what we call that clarified water, dah jernih lah. So dia akan keluar kat sini. Okay, next is the examples of the rectangular and also the outflow clarifier. Yang saya pernah pergi di SAJ, they use this type rectangular basin macam ni. Okay, so in order for them to control the flow is by using this beer macam gigi ni kan. So the process is how they maintain the flow of the sedimentation tank. Okay, these key parameters and also the typical value for the design of the settling tank. Okay, so basically the surface overflow rate must be around 20 to 35 meter cube per day for meter squared, 1 meter squared. Detention time 2 to 8 hours. Okay, masa tahanannya. And then a view overflow rate between 150 to 300 meter cube per day for 1 meter. Okay. So this one, in order to distribute the flow and suspended particle across the section of the settling zone. Sludge means is the flux that being settled, right? Dah jadi sludge. And then to remove the settled water from the basin that carry away all the flux we have this outlet zone where they also have this effluent weir. Air yang keluar lah lepas dia dah jernih yang semua kotoran, all the flux are being settled in here. Okay, we can calculate the diameter and the depth of the circular clarifier. For example, when the water treatment plant they use circular clarifier like this. Ini okay, for a design flow of 3,800 meter cube per day, overflow rate of the 0.00024 meter per second and detention time 3 hours. So we can calculate the weir loading rate by assuming the total effluent weir is 20 meter. Okay, weir purposely allow to control the flow. Yeah. So first, this is quite straightforward calculation. To calculate the weir loading rate. So first we need to calculate the volume. So as we know that volume is the flow, this is the Q, divide by the time. Okay, 3 hours tadi kan? The conversion lah for 3 hours. So we got the volume is 475 meter cube. So Q is 3,800. Kita convertkan dia kepada second 0.044 and then surface overflow rate, alright, so 0.4044. So from here you can calculate the area so 183.3. So from the area you can get the depth, okay, 2.59 meter, diameter 15.3 meter, then weir loading rate is a Q divided by L. L is the length. Total effluent weir is 20 meter. Okay. Okay, so that means this is still within the what we call this weir overflow rate ni kan 150, sorry. Kan dia punya range dia must be around 150 to 300 kan. So if you receive in here weir loading rate is 190 meter cube per day, that means the calculation is okay, correct. Okay, ada soalan tak setakat ni? Is there any question? Okay, then next one is you can determine the surface area of the sedimentation tank. If the design flow is 0.044 meter cube per second, use a design overflow rate of 20 meter per day, find the depth of the sedimentation for the given overflow rate and detention time. So first, you convert lah dia punya flow rate tu kepada meter cube per day ni. Surface area is the Q divided by overflow rate, dapat 190 meter cube. So in here, because Length to width dimension is they have the ratio here. Is either we use 2.1 length width 1 macam tu between this. Then the length seldom exceed 100 meter. So minimum of 2 tanks is always provided. Biasanya 2 kita punya tank ni sedimentation tank. So length 190 meter cube meter squared because usually in the what we call that water treatment plant, they have 2 tanks of the sedimentation tank divide by the 5 meter wide, so kita dapat 19. So length to width ratio is 3.8 ratio 1. Yeah. Okay, so masih lagi dalam within the area. This one the ratio. Find the tank depth. So you must remember that detention time for the conventional of the sedimentation tank clarifier sama je lah ni. Sedimentation tank, sometimes the term they use is settling tank, sometimes clarifier, but all are the same. Benda yang sama je. Which means this process is to do the settlement of the flocks. Okay. So detention time of 120 minutes is we have this volume here. Then we can get this volume dia. Sebutkan ya. So depth is 158 meter cube divided by 95 meter squared. So you will get the depth is 1.7. So the dimension is 5 meter times 19 meter long and 1.7 meter deep. Okay. Okay, actually in the water treatment and also the wastewater treatment, both of these plant, nanti saya akan terangkanlah what does it mean by water treatment. Okay, now we are in water treatment process. In chapter 6, we have this wastewater. Maknanya kita punya air kumbahan in chapter 6. Okay, still we have this quite similar process which is on the in water treatment we call it as a sedimentation, but in the wastewater treatment we call it as a treat chamber. Okay. Ni term-term lah to make sure that you are not confused with this two process ya. Nanti saya akan terangkan lagi. Okay, and then this is examples of the outflow clarifier. Where you can see the directions of the flow. The liquid flow in here comes from the bottom up ya. Bottom kat sini nanti how the settle particle will do this the process. So you must know if the settling velocity is greater than settling of the particles. So is either we want to make sure that 100% of the particle remain in the tank ya. That's our main objective. So in here, the settling of velocity of the particle is a 2.8 millimeter per second and the overflow rate of the upload clarifier is a 0.56 centimeter per second. What percentage of particles are retained in the upflow clarifier? So in here, just we note that if the settling velocity settling velocity is lower than our overflow rate, right? Okay, then that means the particles remain in the tank is 0. Tak ada yang remain in the tank. Maknanya semuanya dah keluar ke next process. Okay, this is the examples of the rectangular basin. Okay, ni pun sama macam tadi. Ni boleh pakai sendirilah Okay, I want to discuss the next two process which is on the filtration. So this is quite also simple process which means we want to make sure the water is sometimes in our what we call it physically it looks like okay fine, but we didn't know. Sometimes it still have some flocks or particles that very small, okay, that we need to filter it out. Okay, so in here usually we use sand or the other medium like coal, garnet, GAC or ilmenite. So we want to make sure that our aim is to treat the water must be minimum 0.3 and below. Okay, lagi jernih lah. Okay, it's very clarified. So these are the several methods classifying the filter accordingly. Okay. So the combination could be sand, coal, arang, yeah, or combinations of both, or some mixed media like coal, sand, and garnet, yeah. Okay. So this is the filtration fundamental. So the water from the sedimentation tank will pass through and get into this filtration process. First is the very fine material, sand, yeah, and then gravel, like much bigger particles, and then the water becomes what we call that, remove all this the still the leftover of the flux, and we can go to this outlet process. So this is the typical properties of the filter media, right? For your information, in terms of effective size, certain the porosity, the sphericity, and so on, the physical characteristics. Yeah. So usually in Malaysia, we use sand and coal. Sometimes they use garnet, but depends on the water quality itself. So if the water means they have a lots of the industrial area in that particular area, so they need to enhance the filtration process lah. Maybe they use multi materials for their filtration. Yeah. So this is the filter design. Okay, so we need to consider the phase velocity, the flow rate, and also the filter surface area. Alright, and this is the slow sand filter requirement, rapid sand filter velocity, and so on. Okay, so this is the slow sand filter velocity, kelajuan dia, and also the dimension for the media diameter, bed depth, required head, and so on. Yeah. Okay, one of the important criteria for the rapid sand filtration is how we do the maintenance. Okay, in most of the water treatment plant, usually they will clean by using the backwashing. So it takes about 10 to 15 minutes by agitating the bed, either mechanically or the compressed air, macam atas bawah, to do the backwash. This is on how they clean the rapid sand filtration process. Yeah. So this is necessary for them to make sure that they do the backwashing so that the filtration will run effectively, yeah, to do the filtration process. Okay. So in here example, for a flow of 0.8 meter cube per second, how many rapid sand filter dimension 10 meter, 20 meter are needed for the loading rate? This one. So first, we can determine the Q in meter cube per sec per day, right? Then determine the total area required. This is the area. So number of filter depends on the total area required, divide by the 10 meter times 20 meter of the dimensions for this sand filter. So that means number of filters must have 2 filters. Okay. Okay, some of the technology here, they use certain bacteria, smart deck. Smart deck is the bacteria that they have form the layer. Okay, consists of bacteria, fungi, protozoa, rotifera. They actually do some degradation process for the certain organic matter. Smart deck ni. Okay. So some of the water treatment plant, they provide the enhancement and they put these formations of the bacteria, smart deck, in order for them to do the what we call it, to do the degradation of the aquatic life organic matter in this during the filtration process, because they can remove certain of this layer can remove the bacteria removal. Okay. Ya, ada new layer smart dia kita panggil. So this technology is actually from the Germany, right? To remove what we call that, certain bacteria that give a harmful to the water quality. Okay, then finally we need to disinfect the water. Okay, this is our last phase, which means we add the chlorine. Usually in Malaysia we use chlorine. Okay, but this is a very what we call it, the handling and safety process is very difficult, because chlorine is very they have a certain SOP in order for handling the chlorine, the gas or I mean the powder. Okay, certain viruses, as you know that now we are living in the what we call that, we get to know this virus. So there are lots of these and others so many viruses in the water system. So that means we cannot see in our with our naked eyes. So we need to disinfect them by using certain mechanism. In this case is for example chlorine. So there are others disinfectant like ozone. Ozone is okay, but is what we call the stability is not really stable like chlorine, because it's just a very short time. UV okay, but the water must be very free of turbid and lens, and it's quite costly, and the others is quite, in terms of the cost, is quite costly lah, but not, it's quite expensive. So this is the common use in Malaysia for our water treatment plant. Yeah. Okay, so you can have a look for the certain disinfectant criteria and also the characteristics. All right. So there are different types of application in terms of gas, in terms of bleach or solid. Like kalau solid ni sebut in terms of calcium hypochlorite. Okay. Tapi yang lebih selamat is typical mixer for the addition of chlorine. So usually they have this inline turbine mixer for the chlorine mixer in here, like this one. They use a diffuser and also this disinfectant supply in here. And this is the chlorine reaction in water, right? For example, if we use chlorine, gas chlorine, so they will produce a hypochlorous acid like this, right? So you can have a look here that how they can revert back to chlorine gas and destroy all of these pathogens. Pathogens means the bacteria that can carry disease. Yeah. Okay, and then we also need to check the residual. Residual means the what we call that, the after we add the chlorine, so where does it goes? How much are the chlorine actually available in the water system? Okay, or dia punya leftover lah. Okay, I think that's all for the water treatment process, yeah, until disinfection. Okay. Any question for chapter 5? If no, Then we can go to next process, which is on the wastewater treatment. I think I already upload the notes in the author. Dah dapat kan? Saya pula, sorry. Okay, wastewater treatment. For chapter 6, in this chapter we have two parts, part 1 and part 2. Okay, so as a introduction, have you today went to the toilet? Dah pergi toilet? Mestilah dah
Yes, doktor.
So usually we did our business sama ada is either small or big, right? So have you ever think about where does your waste go? Kat mana after you flush whatever it is, then where does it goes actually? Siapa tahu? Nadia?
Ya.
Soalan dia tadi apa? Entahlah, malah nak dulu. Maksudnya, in the toilet kan, after you flush lah whatever waste it is, then dia pergi ke mana?
Dia pergi ke tempat yang kumpul tahi-tahi.
Tempat kumpul tahi. Okay.
Sewage.
Sewage. Okay. Okay, that's correct. Okay, this is one of the aspect of the civil engineer is the public health. Okay, because long time ago, kan, usually when you want to do your business, then you just orang dulu lah, masa tu 1950s, right, 1960s, dia kalau membuang, dia don't have a good system, just pergi mana-mana, then even ada yang collect air tu dan buat baja, yeah. That was lah berapa tahun yang lalu lah. Saya tunjukkan kejap the history of in Malaysia, what happens to our sewerage system. Sistem pembantuan di Malaysia ni daripada IWK, because sometimes saya panggil lah orang IWK to give a talk, right, about their process IWK. Indah Water Consortium is the consortium that treat our air kumbahan ataupun ni. Okay, prior to 1950, tak nampak sangat ni. Inilah macam if you kalau nak membuangkan air besar ke kecil kan, terus direct ke sungai macam ni kan. Okay, on the beach pun boleh. Ataupun ada yang kalau ada sistem ni, ada yang collect macam ni kan. Collect tujuan dia ialah dia nak jadikan baja. Macam ni. Adalah yang datang beli ke, tak pastilah beli ke pun dia akan collect. Okay, direct terus sini pun ikan besar lah sebab dia dapat very good nutrient kat sini, right? Okay, so this is kita panggil sebagai poor flush, right? Tapi the problem is it invites a lot of issue in terms of public health. Kan, bila in hygiene macam tu, so banyaklah isu cholera dan sebagainya. Right. So due to some industrial revolution dan sebagainya, so they move forward to septic tank. Septic tank ni maknanya setiap rumah tu they provide apa namanya, provide their septic tank. So ada dalam bawah tanah lah, right? For community kan, ini kalau biasanya for individual house. For community in 1970s, dia apa pun lahir lagi, dia dah ada imhoff tank kat sini. Ada tangki macam ni tapi very quite small. Then 1980, most of the residential area, they are needed to provide a oxidation pond or aerated lagoon. Dia macam kolam-kolam besar kan kat taman perumahan. Masa zaman saya dulu ada tapi most of the time now they convert to the small system, mechanical system due to the land space lah. So baik daripada dia apa namanya, oxidation pond ni dia tambak ke dia buat rumah baru lebih menguntungkan. So dia akan provide very small by using the mechanical system to treat the water, the wastewater. Then after that in 1990s, they have this activated sludge biological filter. Ni benda yang the concept is same because still being adapted in Malaysia because we still apply this activated sludge and biological filter as our main process in our wastewater treatment plant. Okay, so in 2000 and now, most of the system being fully mechanical system. So that means you will see more what we call that, squeeze area. Okay, dia kecil saja dia punya logi, tapi they can operate or treat most quite numbers of residential area. Satu taman tu mungkin besar tapi dia punya logi rawatan air dia tu taklah menggunakan apa namanya, ocean pump macam dulu lah, ya. Itu kisah dia, the history. So this is their concern lah. If we didn't do the proper treatment of the wastewater, because as we know that wastewater contains lots of unwanted, what we call that, viruses and also the bacteria. So most of the disease that we can get from this inefficient wastewater treatment is typhoid, cholera, dysentery, polio sometimes and hepatitis. So it's quite serious, yeah. So since then, our government endorsed this environmental law to make sure that all of the house, okay, is either individual house ke or community or residential area must provide this one wastewater treatment plant. So this is under the Act of the Quality of Land Building, Environmental Quality Act for the sewage since 2009. Okay, but this Act of the Environmental Quality Act is since 1974. Okay, I will share this slide because this is from the IDBK, which is very good for you to know the extra additional slide. Okay, so back to our slide. So we have these 9 subtopics to cover on the wastewater treatment, right? Types of wastewater, effluent discharge, hydraulic and organic loading, preliminary treatment, primary, secondary treatment. Okay, secondary treatment ni yang paling penting lah. Okay, the objective of this of this chapter is to describe the types of wastewater, right? To understand the flow process of the wastewater treatment plant and to eliminate the pollutants and toxicants from the wastewater. Okay, chapter 5 is on what? Chapter 5. No, Adila. Chapter 5 is on what?
Water treatment.
Yes. Okay, water treatment means the water treatment plant, they produce clean water, right? Betul? So after we receive the water, kan ada tap water semua supply in our house, kita gunalah for our mandi activity. Okay, kencing, berak, we do the laundry, we do the cooking, lagi apa yang menggunakan air. Kita ambil wuduk, kita bersihkan rumah, right? So all of this activity finally they end up as a wastewater, unwanted water. Kita dah guna dah. So the next process which is on the chapter 6 is wastewater. Dah pakai dah air tu, kita dah pakai dah dengan senang hatinya. Kan tadi dah we receive the water, right? In chapter 5 we know the process of the clean water. So this one after we use then we discharge. So can we just discharge right away in our drain ke? Boleh ke? So that's why we need to know the process of this treatment for wastewater. Faham ya? Sometimes yeah, okay, thank you. So sometimes we use wastewater treatment plant, sometimes we use sewage treatment plant, sama je, asalkan ada taik itu ialah sewage lah. Dia ada inclusions of pieces. So as a human being, as a normal human being, kita memang kita makan, our bodies we process and we discharge. Tapi kalau kita makan, tak tahu lah macam mana dia, tapi tak discharge, pelik lah, kan? Kita mesti membuang. So that's our concern. So that means we need to know how many is our population. So in one particular area, taman perumahan ke kan, ataupun one condominium ke, apartment ke, how many is DPE, population equivalent, berapa orang yang akan duduk. Because we need to calculate how much is the discharge, the wastewater, sewage. So the developer needs to provide the sewage treatment plant. Because this is compulsory for them to follow, to provide. So the domestic sewage wastewater treatment plant consists of the residential area, of course, okay, rumah lah, commercial outlets, okay, shopping mall kan. Ni pun kena tahu jugalah if they have a shopping mall, everything lah. Kalau we have the mosque, any worship area, mesti ada toilet kan. Bila toilet, okay, that means how to manage that, the wastewater. Recreational activities, semua kena ada toilet, kena ada, we need to accommodate the toilet. Stesen minyak kan, semua ada. Kalau stesen minyak tu dia akan gunakan septic tank lah. Because that's a separate from the wastewater sewerage network ataupun sewerage punya laluan ni lah untuk dia masuk ke loji. Okay, what does it mean by effluent here? Effluent tu apa? Siapa boleh jawab ya? Kakak lah. Jin Ziang.
Yeah.
Effluent. What does it mean by effluent here?
Sewage, the sewage.
Sewage? Sewage apa?
Discharge into the river.
Sewage apa yang discharge into the river?
The QS.
Dia
The wastewater.
The output lah, output, right? Output of your wastewater lah in this case. Betul.
Yes.
So in this regulation in Malaysia, right, treated effluent discharge and standard. Okay, sekejap treated effluent. Macam confused sikit ni. Kalau ni nampak senang sikit nak faham. Saya refer yang AWK punya lah. Saya rasa macam tu ada silap sikit. Dia ada standard A, standard B ya. Kalau saya tengok kat sini, rumah you ni contohnya dekat mana ya? You nak rumah you kat mana? Sekejap, saya panggil ni, tidak semua senyap je. Bagi saya contoh, Muhammad Daniel. Contohlah rumah Daniel dekat sini lah. Allah, baik pun susah ni. Sedih lah Muhammad Daniel ada? Senyap je. Okay, contoh Muhammad Daniel punya rumah in this area. Okay, in this area, we need to know the water intake in that area. So in this case, this is the water intake. Perasan tak ni air yang masuk ni? This is the water intake. Saya nak tulis sikit kejap. Tapi sebab dia, saya tulis dekat laptop kan, laptop ni berdiri. Ni nampaknya saya kena install yang saya punya paper, digital pen yang biasa tu lah senang saya nak tulis. Okay, this is the water intake ya. Nampak tak dia punya flow air dekat sini kan? So this is the water treatment plant, WTP. Kalau rumah Muhammad Daniel kat sini, ni kat sini. So that means dia ada WK kan? Because before the water being discharged to the river is our main water supply. Setiap rumah ni, every of this residential area must, the wastewater or sewage must go through this wastewater treatment plant or sewage treatment plant, sama je. Ada WK kan? In Malaysia ada WK lah. So bila they discharge here, dah treated kan? Dah treated, they must follow standard A. Standard A tu apa? Ni. Dekat atas intake tadi. Standard A. So dekat sini P1A, contoh kalau BOD 20, dia lebih stringent. Sebab dia atas intake. Kan? Bila dia keluar kat sini, when they discharge the effluent ni treated yang keluar dah treated. WK dah treat the wastewater that comes from this area. Nanti dia akan masuk ke sini, water intake. So it must go and follow the standard A. Macam tadi BOD, the requirement is 20 mg per liter. So that the WK must check regularly. The BOD intake must below than 20. Okay, in here Department of Environment always do the monitoring for this IWK punya effluent, treated effluent. Okay, was if for example Kevin punya rumah kat sini kan, Kevin childization. Okay, sebab dia dah selepas daripada intake, tapi still we need to check the effluent treated kat sini, right? So rumah Kevin must comply with standard B sebab dia dah after the water intake. So in here, in this case, for P1B, standard B, for example BOD hilang, dia punya requirement is 50. Kalau over than 50, then ada BK kena saman lah patutnya. Sebab dia tak comply dengan effluent standard. Faham tak? Dia yang penting ni you must know the location of your water intake because water intake is our main concern. Because we want to treat again the water for the consumer. Nampak? You must know the circle, right? The water intake, okay, the process the water, make it more clean water, dia akan supply ke rumah balik. Okay, kat rumah you dah gunakan untuk mandi, berak, kencing, keluar kan as a wastewater. Dia pergi ke IWK. IWK akan rawat, IWK will treat the wastewater and discharge as a effluent treatment. Effluent discharge. The treated one. So, they must follow standard A, referring to this water intake. Okay, so, for example, P1B, P1A, P1B, P1C, P1D, P1E, P1F, P1G, P1H, P1I, P1J, P1K, P1L, P1M, P1N, P1O, P1P, P1Q, P1R, P1S, P1T, P1V, P1W, P1X, P1Y, P1Z, P1H, P1I, P1J, P1K, P1L, P1M, P1N, P1O, P1P, P1Q, P1R, P1S, P1T, P1V, P1X, P1Y, P1Z, P1H, P1I, P1J, P1K, P1L, P1M, P1N, P1O, P1P, P1Q, P1R, P1S, P1T, P1V, P1X, P1Y, P1J, P1K, P1L, P1M Yang ni still, walaupun dia after the water intake, still we need to check the effluent. But the category is fall under standard B. Okay, guys, understand? Okay, tak apa, don't worry. Yang ni still saya akan masukkan dekat author slide ni lah. Kalau saya tengok siapa nak faham yang satu lagi ni. Okay. Okay. Sebab ni kena ada, tahulah punya ni water intake dia. Tapi kena ada WK punya logi seperti ni. Kalau yang tadi nampak lebih jelas lah. Okay, sama saja macam tadi slide IWK, same ya. For example BOD, saya ambil BOD sajalah, BOD. For BOD, if standard A, which is before the water intake, is more stringent, lebih ketat sikit lah sebab dia atas daripada water intake, air yang kita akan collect as a water intake. So 20, dia punya BOD 5. Instead, for standard B is your residential area is after the water intake, but still we need to monitor in terms of water quality because water is circle 50. So that means because we play around with this water cycle, what we give is what we get back. Betul tak? Kalau kita buat pencemaran, if we pollute the water, remember that the water comes again to us. Okay. If we treat it very well, the water we didn't pollute, right? We always appreciate the water, it will give us in a good way. So always remember that. Okay, this is the guideline for sewerage. You can see from the SPAN website of because Suruhanjaya Perkhidmatan Air Negara is the one who manage our sewerage and also our water treatment. So they have lots of the guideline in here, right? In terms of technical specification, if you want to design new logi kumbahan, okay, STP, the new STP for the new residential area, you need to get the license from the SPAN. Okay. So basically, this is the process of the sewage treatment plant. Okay. So this is your house. So the house must be have the sewerage network connection, okay, where it will pump the sewer, the sewer pipe right here, go to the sewage treatment plant, STP. In Malaysia is under the IWK. Okay, so they will do the process. So for this chapter, basically we cover on what's actually happening to this process of the treatment plant, apa yang berlaku dekat sini, dan juga how to manage the sludge. Dua benda, part 1, part 2. Okay, sebab flush pun benda yang critical on how, because if we don't manage the sludge effectively, then it will give a very, what you call that, effect, hazardous effect to the environment as well. Examples ada IWK STP bonus, very big one. Ni dekat mana ni? Ini asamanya ke dekat area KL Selangor kalau tak silap. Yep. Oh, dekat KL bonus regional sewage treatment plant in PT Wangsa KL. Oh, tengah bandar. So this is the process of the typical treatment process flowchart. So we have primary screen, the pump station, secondary screen, grease removal, balancing tank, and primary sedimentation. So this is under the Malaysian Sewerage Industry Guidelines. And then the most important thing is the biological treatment. In this case, we actually rely on the microorganisms to do the process. Macam tu. Okay, basically bacteria is a negative thing, right? But in this case is actually they are our labor, pekerja. They akan degrade the organic matter. Kita punya tahi. Okay, so this is the overall process. Nanti saya akan terangkan one by one. Right, the typical sewage treatment flow process. Tadi kata sewage wastewater, ni sekarang sewage pula. Sebab dia kita ada tahi, feces. Okay, so when we have feces included, then we can call it as a sewage treatment plant. Okay. So the typical process in Malaysia run by RWK is firstly we have this raw kan, air yang fresh dari ladang, dia dari rumah. So kita ada coarse screen yang kasar dulu, kita ada pump sound, kita ada fine screen. First kita kena buat grit removal. Okay, grit removal is to remove all of this like material like sand, okay, particle and the heavy particles yang tu kena remove dulu. Sampah-sampah. Then we have this grease trap, minyak semua grease trap. Then we have this NOC tank to do or prepare for the next process of aeration. Alright. Okay, we have aeration to improve the water. Then the next process is the biological process, which is clarifier. Ini yang kita actually menggunakan our microorganisms, good bugs, okay, to do the biodegradation of organic matter, right? So yang the brown color is the sludge formation, sisa lah. Okay, the sludge will be managed like we do the thickening or we produce the biogas from the anaerobic digester, or we produce the sludge cake by dewatering it. Okay. After all of this process run by the IWK, the treated one, we call it treated effluent, will be discharged into the river. But remember, like I said before, the treated effluent must be checked regularly. Okay, it's either standard A or standard B. Okay. So I would like to ask Haris Dahlan.
Yeah.
So what does it mean by standard A?
Standard A. Standard A daripada upstream.
Upstream, ya betul. Upstream
Of the flow.
Of the water intake. Okay, water intake. Water intake, kalau ada logi lautan air, contoh kalau kat Johor, we have the Runhill SAJ kan yang take the water for water supply.
Yeah.
We need to know.
Okay.
Kalau upstream is standard A. Kalau downstream, we need to use standard B. Means it is located after the water intake.
Oh, okay.
Okay, so water intake tu specifically we use for the water treatment, water supply. Maksudnya air tu kita gunakan untuk bekalan air lah. Okay, that's good. So these are the contaminants of concern in sewage treatment plant. Of course, we have lots of this suspended solid, right? Biodegradable organics. Okay, bayangkanlah when we do the our activities, right? We do the cooking, we do the washing, bathing, they can put laundry, urinate, kan? Your big business, semua tu kan is our wastewater, right? So adalah biodegradable organics, ada pathogens, we also have nutrients, right? Refractory organics, heavy metals, so very complex. Ini yang kita kena rawat. Okay. First, we need in order for us to know or design the wastewater treatment plant or sewage treatment plant, we must know the peak flow factor. Tadi saya kata tadi lah, if we want to have a new development area, residential area in one place, jadi they must provide the STP, sewage treatment plant, right? So the developer must provide the information of how many houses that they were going to build. Okay, in one house, particularly how many populations, right? So how much is the wastewater that going to be generated. Faham tak? So in order to calculate the peak flow factor, you need to calculate by using this formula. Yang ni semua ada dalam Malaysian Standard Code of Practice for Design and Installations of Sewage System. So P means is the equivalent population in thousand, yeah. So it's quite simple lah for me, yeah. PE is based on this table. PE ni, population equivalent ni, PE, yeah. Okay, kita assume that one residential is 5 person per one unit. Averagely lah. Kerana ada yang duduk 2 orang, ada 10 orang, tapi kita ambil average, 5 lah. Okay, commercial, berapa gross area. So yang ni kita akan kira dia punya peak flow. Alright. Taxi terminal, mosque, church or temple, stadium, blah blah blah. Airport ke, so how many, 0.2 per passenger per day or 0.3 per employee. Okay, so this is the number to calculate the peak flow. Okay, for example here, calculate the peak flow for a new development area consists of 250 unit houses. Very simple kan? Okay, 250 unit houses kalilah dengan 5 PE. Mana dapat ni? Okay, when you refer back to this table for residential 5 per unit. Jadi kali je lah 5. So kalau ada 250 residential houses, so 5 PE per house. So 1250 PE. Okay. Okay, dry weather flow ni, this is from the guideline. Dia memang bagi ni 3 to 5 liter per day per capita according to Malaysian weather. So this is given. Hydraulic flow is 1250 PE times 2 to 5 liter per day per capita. Ni flow air lah, air yang kita assume for one day. Per capita means per person. So 281,250 liter per day. So hydraulic flow is 0.003. So in order for you to calculate the peak flow, kira lah kat sini. So you will get the peak flow is 0.014 meter cube per second. Okay, you can try here for the tutorial. Okay. One market of the 20 stalls and 1,100 unit houses. In here you can calculate the PE, hydraulic flow, peak flow factor and peak flow. Senang je. Macam nak kira ni? Seng Chua. First what we should do to calculate the PE. Buang Seng Chua ada?
Ada.
That's what we should do to calculate the peak flow. Kita kena refer apa? What we should do at our first step.
Nak cari population dulu.
Yes, kalau one market for 20 stall, cari market. Where is it? Ni kan? Number 7, right? So 3 per stall, 3 PE per stall. How much PE required? 20 stall. So that means 20 stall times with 3 PE. Betul? Saya pula beri jawapan. Okay, you try dulu. Try dulu nanti saya datang balik. Semua orang pun boleh try juga. We can have a look your answer. Okay. Dah ada siapa yang dah ada jawapan? The first question. Senang je kan? Wang Senchua dah dapat dah? So yang first 20 stall berapa kita punya peak flow? Ada yang cuba? Ada yang dah dapat dah?
60 doktor.
60. Okay, yang lain? Okay, thanks Wadila. Peak flow 60. Yang lain macam mana? Muayyad, how much do you get? Muayyad Mansur? Semua dah tak ada, tidur ke ni? Yang lain dapat juga 60 PE. Okay, no response. So you can use this as a, what we call that, your tutorial, because this is quite straightforward. There's an example there given. Okay. So next is the organic loading. Okay. The organic loading is also one of the main criteria for the design. So how much is the value for BOD? BOD is actually our organic matter. Okay, organic matter that flow into the wastewater treatment plant. Okay, how much is the also the what we call it suspended solid? Okay, the particle COD. It also carries some chemicals. Total nitrogen contains nutrients. Okay, mungkin daripada baja, from the landfill kan dan sebagainya. Ammonical nitrogen, right? From the aquaculture, there are lots of the sources for the ammonical nitrogen. Total phosphorus, right? Oil and grease, there are lots of these organic loadings. Okay, that come from the wastewater. Okay. Yeah. Boleh move. Okay, boleh move. Kita tak boleh move. Okay, first of the process in the wastewater treatment plant is the bar rock and screen, like a screening lah. Because we want to make sure that there is no other objects or waste, solid waste, kan, sampah or rubbish can entering the system. If not, they will disrupt or what we call that, disturb the mechanical system that available in the wastewater treatment plant. So here is the barracks, okay, in order to remove the large objects or particles here like this or rubbish. Okay, then we need to have this grid chamber. So the purpose of grid chamber is to what we call that, to remove the solid like eggshells, sand, gravel. In here, in this case, we remove by the gravity settlement or centrifuge. Okay. So the grid particle is something that cannot be broken down by any biological treatment. Okay. Sometimes runoff from the road, right? Having these particles, gravel, sand, and everything that entering the wastewater treatment plant. That one we need to remove it using this grid chamber. Okay, so this is the design parameters for the grid chamber. Right, and the grid remover is either we use for manual tanker by using the tanker or mechanical. If the population equivalent is what we call that, more than 5,000, so we need to use the mechanical system. Okay, this is the chamber type, and you can see the minimum detention time, masa tahanan dia, maximum gravity flow, and also the centrifugal, and this is the chamber dimension, depth and width. Okay, so all of these criteria are actually stated in the Malaysian Civil Industry Guideline, MSIG Volume 4 section. So there are three types of the grid removal. Okay, system and comprise either the horizontal grid chamber, aerated grid chamber, or the treater. Okay. So these are their specification. Okay. Muhammad Shukri, what's the functions of breath chamber? Muhammad Shukri bin Jalal. Muhammad Shukri tak ada Norliana Aida. Norliana Aida ada? Semua dah tak ada ke macam ni? Sisa seorang je? Norliana? Okay. Mak Rosa. Okay, Nur Adila. Nur Adila dah macam dah tanya tadi kan. Nurul Fatimah. Nurul Fatimah binti Helmi. Lee Zikiai. What was the functions of breath chamber? To slow down the flow. The purpose of breath chamber is what? To remove the grit. Grit means like grit particles like sand, gravel, right? Macam tu lah. Something discrete particles yang maknanya they have this besar lah, eggshell, sand, gravel that we cannot biodegrade in biologically. That's the purpose. You must know first the purpose. Then the process is like this. Okay, detention time to remove this breath chamber. Okay. So for this example, design a rectangular horizontal grid removal to remove grid. Grid ni something heavy, okay? Heavy like sand ke, gravel ke, benda batu-batu kan? Because we don't want this to disturb the process in the wastewater treatment plant. Okay, ada bagi specific gravity of 2.65 and particle settling velocity ranging of 0.016 to 0.022 meter per second. So the horizontal velocity will be maintained at 0.3 meter per second by using the veer. So determine the channel dimension for a maximum wastewater. Okay. Let's go. Okay. So in here, in order for you to design rectangular grid removal system, to remove the grid kan, ni kat grid lah. Benda-benda yang heavy tadi, macam sand, gravel, lagi apa benda yang batu-batu lah, yang kecil-kecil tu kan. Alright, so you first you need to know the depth of flow in here. So knowing that the detection time is 60 seconds, right? Detection time 60 seconds, setting velocity is 0.016. So you can know the depth of the flow, 0.96 meter. So in here, you provide 0.3 meter freeboard and 0.25 meter grid accumulation zone depth. Okay, and hence the total depth is, you need to calculate, you need to sum up the depth 0.96 plus 0.30, okay, and 0.25. So next, you can calculate the length of the tank by using this equation. Given the horizontal flow velocity is the 0.3 meter per second, right? So the length 60 times 0.3, 18 meter. So provide 25% additional length to accommodate the inlet and outlet zone. So the length of the grid chamber is 18 times 1.25, so 22.5. Dan dapatkan width, kita tahu width from the area, cross sectional area, Q times dengan velocity, lalu velocity kan, horizontal flow velocity. So QA, so you can get the width, lebar dia in here. Okay, I think I will finish until the equalization tank. Sikit lagi So the wastewater treatment plant, alamak ada call kejap hello. Salam. Ya boleh kejap, saya ada kelas ni, saya off kan kejap.